Hello friends, I'm a part of the group 12 of the internship program offered by Bennett University, Noida. The project that we are working on is titled Network Traffic Classification for Software-Defined Networks using CNN and RNN. Software-defined networking is a network architecture approach that enables the network to be centrally and intelligently controlled. This helps the operators to manage the entire network consistently. SDN suggests to centralize the network intelligence in one network component by disassociating the forwarding process of the network packets, that is the data plane, from the routing process, that is the control plane. The control plane consists of one or more controllers which act as the brain of the SDN. The dataset which was given to us was custom made by Leadingindia.ai, consisting of 23 features, including the output label. The output label denoted whether the traffic was attacking or of the normal type. The first task was to pre-process the data in the dataset. Pre-processing involves removing the redundant values in the dataset, identifying the types of the variables, that is whether it is numerical, categorical, etc., and encoding the categorical variables. It also includes identifying those features which affect the output label directly, as well as those features which affect the accuracy of the machine learning and deep learning models which we develop. Further part will be explained by my teammate.
After the pre-processing of the dataset, various machine learning classifiers were implemented. These classifiers gave us results, but we could still increase the accuracies. In order to increase the accuracies, we used various ensemble learning techniques. The first ensemble learning technique that we used was bootstrap aggregation. Bootstrap aggregation was implemented to all the classifiers that we used before, and we could see a significant increase in their accuracies. The second ensemble learning technique used was gradient boost as well as XGBoost algorithms. These algorithms gave the highest accuracies. After finishing up with the machine learning part, we started implementing a simple neural network for binary classification. This neural network only had 2 hidden layers, and it gave us an accuracy of around 99.43%.
The problem with simple AM is the high model complexity due to the high dimensions of our dataset. So to reduce the model complexity, we used a stacked autoencoder to reduce the dimensions of the dataset, and then the reduced dataset was then fit to the simple ANN. This resulted in improved accuracy score and also low convergence time. The main model we were working upon in this project was the CNN LSTM model, and the method used is very similar to those in the case of classification, time series classification or sentiment classification with CNN LSTM. The first layer in the model is the convolution 1D, followed by max pooling 1D, and the layers upstream are either 1 or 2 LSTM layers. And the final layer here used is the dense layer with sigmoid activation. The convolution 1D assumes 2-dimensional data points, and our data point are 1D, so we put the second dimension to 1 to make it 3D. And at last we also worked with some other low complexity models like the self-organizing map. The idea is to split the dataset according to protocol, and for each protocol fit a separate SVM to the data. The problem with linear SVC is that if the points happen to lie within the margin of the classifier, then they can be misclassified. So in this case, inference from SOM or random forest can be used to resolve this issue.
To conclude, we have done network traffic classification for software-defined network traffic, which was given to us by Leading India. We have applied various machine learning and deep learning techniques to classify the traffic into normal and malicious classes, out of which the hybrid models consisting of SVM random forest and SAE MLP achieved highest accuracies.